Okay, this is part 5 in this series devoted to Improv Card Magic. Now today we will begin with 14 card packets. Okay, so I have a shuffled deck of cards here. And as you can see, we're going to look at something I haven't shown you yet. It's a kind of cool system for keeping track of the number of red and black pairs in such a way that you don't mentally become overwhelmed with the job. Okay? In fact, why don't we just take a minute and kind of explain this. So let's say we have these 14 cards here, and these are the colors of the cards starting from the top of the deck. So red, red, black, 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 and so forth. Okay, so here is a very interesting, simple system for keeping track of the number of red and black pairs if a person wants to go that route. So what you do is you associate with 2 red the number 10, okay? And then associate with 2 blacks the number 1. And then opposite color pairs count as 0, so essentially just leave those, ignore those. Okay, that's probably the easiest thing mentally. So just skip those. So I see a red pair, so I think 10, and then I see a black pair, and I add 1 to it. So now in my mind I'm just thinking 11. Okay, so that's the number I'm thinking. Okay, nothing, nothing. Oh, I got another 10. Well, 10 plus 11 is 21. Come over 1. Oh, I got another 10 plus 21 is 31. And then over here, oh, I got a pair of black cards. So we add 1 to that, 31. So we get 32. So in my mind, I just need to remember the number 32. And remember that the tens place, the digit in the tens place, tells me how many red matching color pairs I have, and the ones place tell me how many black color matching pairs I have. So if I can just hold on to the number 32 throughout the performance, I can reconstruct the number of pairs that will either be red or black. Okay, so I thought this is a fun system to share with you, especially as the packet sizes here are getting a bit bigger. Okay, so as always, we need 3 random piles here of 14 cards each. So let's go ahead and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 3 piles of 14 random cards each. So what we'll do is we'll go ahead and just put these out of the way for a moment. And then if you remember, what we do is we pick up any of the 3 piles, actually. And then at the start here, just for the sake of the performance, my presentation here, we're free to look for an AMP mirrored or 2-cycle structure for the first pile that we pick. Let's take a look at the next pile and just see what Lady Luck has given to us. Now, since we've already taken up our AMP structure, we're limiting ourselves, kind of artificially, superficially, to a mirrored structure or a 2-cycle structure. Okay, so glance at it as a mirrored structure. Looks like it could be actually pretty good if we use our little system here. So let's look. So as a mirrored structure, what do we get? Well, same suit even. So a black pair counts as 1, so we get 1. Here's a red pair, that's plus 10, so it counts up to 11. Plus another 1 for a black pair, that's 12. Nothing. Plus another 10 for a red pair, that's 22. And then a black pair that add 1, 23. Another black pair, 24. Ooh, that's kind of nice. So if we just hold on to the one number, 24, think there's 24 hours in a day, right? Or something like that. We could reveal in the end that we've put out pairs where 2 of the pairs are red cards and 4 of the pairs are black cards and the other pairs are non-matching color pairs. So I think we can hold on to 24. So 24. Okay, so we'll put this in the middle. Okay, so let's go ahead and move on to our mirrored structure that we made note of here. So the middle column here. You may recall, what is it that we made note of for this packet? Do you remember what number we needed to remember? It's a 2-digit number. Yeah, 24. There's 24 hours in a day. So remember, so the number we're needing to remember. Now, as always, you need to realize that for the sake of this educational video, I'm doing 3 presentations in one. Now, you normally would not do that. You would choose just any one of these for a particular packet, okay? So you're really not having to remember all 3 of these. That might be too much for most people, including myself. You're just needing to remember just one of these for a performance. And so here we just squirreled away that 24, and we kind of associated it with, oh yeah, that's the number of hours in a day. That might help us remember. And then, of course, remember the 24. What does it mean? The 2, the tens place, tells us the number of red pairs that we're going to reveal in the end. And the ones place, namely the 4, tells us the number of black pairs. Okay, very good. So just kind of keep that in mind. So we're viewing it as mirrored right now. Being mirrored, of course, we have the stay stack principle. One of the consequences of the stay stack principle is that a Pharaoh in and a Pharaoh out shuffle preserve mirrored packets. Okay, and you can see that if you go to line, so on the left in our table, line 12, it says Pharaoh, and it will preserve a mirrored structure. Okay, so do you remember how a Pharaoh goes? Okay, so you just kind of fan out the cards so you can kind of see them. So what we're needing to do is split the cards exactly in half. So you can just break these off like that. And now you're free to interlace these in any way that you like, but they do need to be perfectly interlaced, every other card. Now technically, one of these, quote, interlacings gives rise to what's called a Pharaoh in, and the other one will be a Pharaoh out. Well, it ends up that both of those preserve mirrored structures. So isn't that wonderful? Now, being mirrored, we can convert it to an AMP by way of the LR to the negative R. Okay, so that's on line 23 on the left. Okay, so that will convert a mirrored structure to an AMP. So let me just remind you of how this works. So it's a dealing out of half the cards, which is 7, but when you go to deal out the next level, you don't do it in the same order, you do it in reverse order. That's why the R is up in the exponent, okay? So you can go like 1, 2, 3, 4, 5, 6, 7. Now, instead of continuing 1, 2, 3, 4, 5, 6, 7, you now do it in reverse. The last one dealt, so we put the next one on top of that. We just go in reverse all the way to the very first card dealt. Okay? So it's like a 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7 in reverse. Okay? Okay, now it is true that we can stack this. Imagine these on a line here. If we had them on a line, we can stack from left to right or right to left. Now there are some other stacking that you can do that I'm not going to show you here. It's called judicious stacking. I talk about it extensively in other places on my video. But here, what would have been nice for you to do, actually, is if I hadn't limited my screen space, what you could do is just deal out 1, 2, 3, 4, 5, 6, 7. And then the next card goes there, 1, 2, 3, 4, 5, 6, 7. Okay, so it's less likely that you'll get confused if you just do it on a line. and it makes the dealing backwards a little more intuitive. Okay. Now we're going to stack what's equivalent to a left to right or right to left. Well, this is the first pile, so if we stack from right to left, it's like going clockwise. If we stack from left to right, this is the first pile, and we go counterclockwise. Okay, so just be aware of that. If you want to do this circular arrangement, that's fine. There's just a little bit more to pay attention to not make a mistake. So at first, I think it's safest just to put them out on one big long line. Okay, so let's say they want to stack them sort of in the opposite order to which we started to deal these out. Well, that would mean this is the last card, last little pile, so you'd go in reverse order. So this would be analogous to stacking from right to left, okay, if the original dealing was left to right. Okay, so if we haven't made a mistake, this should now be an AMP structure, and we'll find out in a minute if we made a mistake, because it's not going to work out for us. So to go from an AMP to a mirrored, a really nice way to do it is the mange shuffle. Mange is on line 13, and that will convert an AMP to a mirrored structure. And mange comes in two varieties, over, under, and under, over. So maybe they'll ask for an under, over. So this is where you push the top card into your other hand, and then it's under, over, under, over, under, over, under, over, under, over, under, over, under. Okay, that's a mange, under, over. It's guaranteed to convert an AMP to a mirrored. Now, since this is mirrored, we still have the stay stack principle, and in particular, we can deal out into 2 piles or 7 for the simple reason that 2 and 7 are divisors of the packet size 14. So I don't know, maybe I'll try something that I'm not sure if it's going to work on this screen, but I'm going to try to deal these out way up here into 7. So we'll get 1, 2, 3, 4, 5, 6, 7. Not quite as nice as I was hoping. 1, 2, 3, 4, 5, 6, 7. Okay. So once again, if you want to just do it on a long line, safer. We can stack from left to right or right to left. Maybe they'll go from left to right. Well, this is the first one dealt. So this would be like stacking from left to right. Okay. Now, so because of the stay stack principle, this is still mirrored. Okay. Now, another thing that we can do is 2 identical overcoats. Okay. Now, I think we've done this in an earlier video. It's on line 7 in our table on the left. So an overcoat is where you deal out half or more of the cards and drop the rest on top. That's an overcoating of the cards. Well, if you perform 2 identical overcoatings, it will preserve mirrored structures. Now, the cards will be in a different order, there's no question, but the mirrored configuration of the cards relative to each other is still there. It's unharmed, okay? So one way to do it is, if you know their first name has somewhere between 7 and 14 letters, you could just use the first name of the spectator. That might be nice to personalize it. Or you can just ask for, we need a random number, let's say between 7 and 14, since we only have 14 cards here. So what number would you like us to go with? And they might say 9. Okay, that's great. So what you do here is you deal out 9 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9. Drop the rest on top. And then you perform that same dealing one more time. You have to do it twice. That's the reason for the 2. So by the way, the 2 and then the next thing that looks like a 0 is actually a O-C. O-C is overcoating. Okay, I just want to clear that up. Okay, so we need to overcoat 9 cards a second time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and those 2 actions taken together are guaranteed to preserve mirrored structures. Okay. And like I said, if you can come up with a word that relates to the spectator in some way, or maybe you know their favorite ice cream is chocolate. Well, chocolate has somewhere between 7 and 14 letters, and so you could spell it out twice and say, well, I'm going to give you 2 scoops of chocolate ice cream, okay, or something like that. So just use your creativity. Okay, so this is still mirrored. Okay, so now what we're going to do is we're going to use the Klondike Shuffle, and we're going to put out even-sized piles of cards and then randomly stack them. Isn't that amazing? Okay, so if this is mirrored, a Klondike Shuffle, what it does is it brings together those special pairings that we noted at the beginning. In fact, if we just do a Klondike Shuffle and deal into a single pile, it will convert it to an AMP, and you can see that. Look at the chart, line 14. The Klondike Shuffle always converts a mirrored structure to an AMP. But what we're doing differently here is you just have the spectators tell you when to stop, like dealing out pairs. You know, maybe they'll want a whole bunch here, that's fine. And then maybe one here, okay? And now you're free to have the spectators stack these or tell you how to stack them in whatever order they like. So maybe they want this one first, followed by the one down here, and then maybe the one way up here, and then the one down here. Okay, these are all free choices made by the spectator, but guess what? It does not hurt the fact that this is an AMP. Okay, and now we're going to do something that we haven't quite done in this way. We're going to use an up jog. Now, as you can see on the chart, line 11 on the left, an up jog converts an AMP structure to a 2-cycle structure, okay? But instead of stacking the 2 halves that come from doing an up jog, we're going to just set them down as separate piles. Well, when you do that, you get something called coupled piles. And we talked about this in an earlier video. So let's go ahead and just bring up our larger hidden structures diagram here. Okay, so here with a 2-cycle structure, if you were to push off 50% of the cards, that's what the P is for, you would create what are called coupled piles, okay? So coupled piles are 2 piles where at each level the cards are, quote, related. They consist of the special pairings that we made note of, okay? So we're really just using the even or odd up jog to kind of get what are called coupled piles. And those 2 piles randomly stacked together will always give you a 2-cycle, okay? But we're not going to stack them this time. Normally we'd stack them. What we're going to do differently is just set them down like that. And now from here, what we know is true is these are coupled piles, which means these 2 constitute one of the pairings that we made note of at the beginning. So what you do is you just say, okay, these 2 are little friends. They're on the same level of each pile. These 2 get along really well. So we're just creating little piles. These 2, oh, they just feel like they belong together. How about these 2? Yeah, we'll put them together. These 2 maybe in the middle there. These 2 together. And then the final 2 together, okay? So that gives us 7 pairings. Well, at this point, we have, quote, a DMP, right? Distinct mirrored pairs. And now we're ready for the reveal, right? And if you remember, the special number we remembered was 24. Well, what's the 2 reminding us of? The 2 in 24. Well, 2 is in the tens place. And if you remember, we associated red pairs with the tens place and black pairs with the ones place, single digit place, right? So 24 says 2 of these pairs are red within the, you know, each pair. And then we have, wow, we have 4. We have 4 black pairs. I'm not sure exactly where they are, but oh, anyway, that's what I'm getting as some feedback here. I'm getting, well, that's interesting too. That means only one of these pairs is of opposite color. Ha! What are the chances of that? Only one of these pairs is a red and a black. Otherwise, 2 of them are red and 4 pairs are black. Let's check. Do we have 2 red pairs and 4 black pairs? Well, there's a black pair. Oh, that's good. Oh, here's a red pair. Okay. Oh, another black pair. Okay, let's see. What about these? Oh, another black pair. We're up to 3. Now, we said we'd have a total of 4 black pairs. We don't want too many black pairs. Oh, wow. We did say that one of the pairs would not match in color. And it was the only pair that would not match in color. Well, we have 1 red and 3 black. So one of these better be a red pair and the other one a black pair. Otherwise, we're dead. Oh, there's a red pair. Okay, we're almost home. We need this to be a black pair. And then my intuition for the matching of these cards within each pair will prove to be 100% accurate. Okay, so what did we get here? Is this a pair of black cards? Oh, it is indeed. Check that out. We nailed it. All of the choices that you freely made led us to an outcome that I was able to sense and state exactly what we would find as we turned over these mystery pairs. Isn't that amazing? 2 red pairs, 4 black pairs, and 1 non-matching color pair. Wow. I wish we could do that every time. Wouldn't that be amazing? Well, you can do it every single time. Why is that? Because of mathematics. You can do it every single time. As long as you don't make a mistake, or as long as I don't make a mistake, it will work every time.